In this video, I'm going to briefly explain motion graphs with the basic motion graphs that can be expanded later to more complex graphs, but this is a good start. So first of all, here we have three graphs, position versus time, velocity versus time, and acceleration versus time. X is position, t is time, v is velocity, a is acceleration, and t is time. An object at rest means it will stay at the same position throughout time, which means its velocity is zero, which means its acceleration is zero. Object at constant positive velocity, it means that the position increases, right, with a positive slope. And the velocity time, since it's a constant positive velocity, it will be a flat line in the positive above the axis, in the positive side of the graph, which is the top portion of it. And because the velocity is constant, the acceleration will just be zero. Now, object at a constant negative velocity, the position will decrease towards zero, or if it is already zero or negative, it will become more negative with negative slope. Since the negative velocity is constant, there's just going to be a line below the horizontal axis in the negative portion of the y-axis, which is the velocity, showing that the velocity is constant with a flat line. And because the velocity is constant negative, there's going to be zero acceleration. Object at constant negative acceleration, it means that the acceleration is negative, which means that the velocity, if it begins at zero, will become more negative, which means we're going to have a curve like this for the position versus time. The velocity versus time graph is the slope of the position versus time graph. Since the slope right here at the peak of this graph is zero, we begin with zero velocity. Since the slope at this portion of the position versus time graph is negative, the velocity becomes negative, and then acceleration is negative. Here's another situation, another condition where the acceleration is negative. Here in the position versus time graph, we start with positive velocity with positive slope, so here's the positive velocity. As we go towards the right, the slope becomes zero, and the velocity eventually does reach the zero at the horizontal axis. The acceleration is still negative, constant. Here's another example, one complete loop, where we start off with positive slope, positive velocity, we reach zero slope, zero velocity, and then negative slope, negative velocity, and acceleration is negative. And here, of course, are my two nums, Zervina and Jürg and Zervina. And an object at constant positive acceleration means the position the rate of change in position will increase. We start off with zero slope here, so zero velocity, and the slope becomes more positive, so the velocity goes and becomes more positive there. So here we have constant positive acceleration. Here we have a negative slope in the positions versus time graph, so we start with negative velocity, and then the slope becomes it approaches zero, so the velocity goes and approaches zero, and you have positive acceleration. Another example is one complete loop. You have positive velocity, you have negative slope here, so negative velocity, and then the slope becomes zero velocity, and then it goes again and becomes positive. So here's the positive velocity. Here's the diagonal to demonstrate this motion. And then, of course, I made a typo actually. So this is supposed to be a positive acceleration. So let's fix the typo really quick. So the positive acceleration is supposed to be right here. I wonder if I did the other ones right. Yeah, I did. So let me increase this, and there you go. And I want to eliminate this this negative here, and that becomes 0, and then problem fixed, sort of. Can move this a little bit this way. So now we have positive acceleration. So positive acceleration, negative acceleration, negative velocity, positive velocity, and at rest. So long story short, there are 4 rules for motion graphs. The slope of a position versus time graph is equal to velocity. Positive slope means positive velocity. Negative slope means negative velocity. The slope of velocity versus time graph is equal to acceleration. Positive slope means positive acceleration, and negative slope means negative acceleration. Motion graphs follow the pattern curve, diagonal, flat, flat, 0. Let's see if this is true. Flat, flat, 0, flat, 0. So that obeys the rule here. Diagonal, flat, flat, 0. Diagonal, flat, flat, 0. Curve, diagonal, flat. Curve, diagonal, flat. Curve, diagonal, flat. Curve, diagonal, flat. And so forth. So it does obey curve, diagonal, flat, or flat, 0, depending where you begin. If you begin on diagonal, then it goes diagonal, flat, flat, 0. If you begin at flat, then it goes flat, flat, 0, and flat, 0. If you begin at curve, then it goes curve, diagonal, and then flat. So here's a good summary of motion graphs. This is a good beginning summary of motion graphs. And I will get in more details with more complex motion graphs in the future. Thanks for watching.